Welcome back for our third day of 5-4 of dividing polynomials. So when we're looking at this, we're going to spend another day on synthetic division because there are some applications of synthetic division. So yesterday we covered the basics of it and we used it to determine if a linear polynomial was a factor of another polynomial. Today I'm going to teach you something called the synthetic process. All right. And what the synthetic process is just kind of a fancy way of evaluating a polynomial. All right, so what I mean by that is, if I'm trying to evaluate p of 3, so you could just substitute 3 in for all of those x's, or you could run it through the synthetic division. Okay, so I'm going to take that 3. Now this time notice, the synthetic process, when I'm already being given a number, I just keep that number. You only flip it when you're dealing with a factor, okay, with a linear piece. So I'm going to use that 3, and then I'm going to set up synthetic division. I have 1x to the 5, no x to the 4s, so remember you need a 0 there, negative 2x cubed, negative 1x squared, no x's, and a 2. So this is also a really good reminder of making sure you use those placeholder zeros accordingly. Now I'm just going to run through that process. Okay, take the 1, multiply by 3, add, multiply by 3, add, multiply by 3, add, multiply by 3, add, multiply by 3, and add. All right, and when you actually go through this, now that we're at the end, when it just says, what is P of 3? Well, P of 3 is actually just the remainder. Okay, so what that's showing you is if I had plugged in 3 to that polynomial, if I had just evaluated it for 3, 122 is the answer that I would get. Okay, and again, just a neat thing is, if you're ever having to do this without a calculator or something like that, this is typically a lot easier than having to deal with all those powers. So really, this is just a method to help you if you're trying to do it quickly without a calculator. But let's step through it again. So I want to find out, given that polynomial, what is g of negative 2? So I'm going to use that negative 2. And I can use synthetic division to evaluate this polynomial. So I have negative 2x to the third, 3x squared, negative 2x's, and a 1. Pull that first one down. Now multiply by the negative 2, add. Multiply by the negative 2, add. Multiply by negative 2, and add. So you can actually see just how quickly you can run through this. So g of negative 2. G of negative 2 is just going to equal that remainder. I could also ask you something like this. Is 3 a 0 of the polynomial? Okay, this is again kind of a lead into what we're going to be starting tomorrow. So is 3 a 0, or another word for that is 3 a solution of that polynomial? Well, let's use synthetic division to find out. So we want to know, is 3 a 0 of this thing? So I'm going to run it through synthetic division. All right, so let's see what we get. Pull down the first number, then multiply. Add, then multiply. Add, then multiply, add. So my remainder is 0. So what that's telling me is yes. Because I ran through 3 and and it came out to be 0, it's telling me that that is in fact a solution to that polynomial. By a solution, remember another term for that would be x-intercept. And we'll come back to that idea in a little bit, okay? We'll come back to that idea starting tomorrow. But remember, all of these things are applications of the synthetic process. All right, so we can also use synthetic division to help with word problems. So if the polynomial x cubed plus 6x squared plus 11x plus 6 expresses the volume in cubic inches of a box and the width is x plus 1 inches, what are the dimensions of the box? So let's think about a plan. So first of all, we need to think about how does the volume of a box relate to its dimensions? Well, volume is length times width times height, right? When we're talking about a box, obviously. So we have the volume and we're talking about the width, okay? So we have volume and we want to know, all right, what are the length and the height? Well, if we take the volume and we divide out that width, that's going to leave us with the other two dimensions for us to work with. All right, so basically, I'm going to take this and I want to synthetically divide this out of this. All right, because we're going to be dividing those two polynomials. And to do that division, let's use synthetic division. Now we're back to using a factor like this. So that means I need my magic number. In this instance, my magic number would be -1. Line up the coefficients of the main polynomial. And now let's run through this synthetic division. Multiply it by -1, then add. Multiply by -1, then add. Multiply by -1, then add. All right. Now, the really nice thing here is now you have a polynomial, or you have something that you can reconstruct a polynomial with. So remember, this is your remainder, and the cool thing is you have a remainder of 0, okay? So that means that this process worked. The x plus 1 really was a factor of that original polynomial. But now we need to write the constant x term, x squared term. So what we have left is x squared plus 5x plus 6. All right, so that's what we have left. So right now we have one of our dimensions, and we saw that these really were factors of the original polynomial. So I have one dimension, now we need to get the other two. Well, how could I get the other dimensions? Well, in this instance, I think you'll notice that this actually factors, all right? If you factor this out, you can get x plus 2 and x plus 3. So these would be the width, the length, and the height of that box. So let's talk about one more application of this synthetic division. So 3 consecutive integers have a product of 120. What are the 3 numbers? Now this one, I will tell you right now, this one is very important. I would star this one. You are definitely going to want to make sure you understand this type of question. So first, let's define a variable that'll let us express the three numbers. So I don't know what these numbers are. So if I don't know what these numbers are, the first one is just going to be x. Now, if I want consecutive integers, well, that means the next one would be x plus 1. And the next one, oh, sorry, and the next one after that would be x plus 2. All right, so now I have something representing my three integers, okay? My three consecutive integers. So I want their product to be 120. Product means multiplying. So I want them to multiply to give me 120. Now, I can't really work with a polynomial like this, and especially I can't use synthetic division on something that looks like that. So I need to get this polynomial in standard form. And if you remember back from section 5.2, the way to get this to be a polynomial in standard form is we need to FOIL that out. So I'm going to FOIL those two together. X times x gives me x squared. X plus 2x gives me 3x. 1 times 2 gives me 2. Now that I have that, I can distribute the x in. So x cubed plus 3x squared plus 2x equals 120. And now, if I want to solve this thing, remember solving always implies you need it set equal to 0. So I'm going to subtract off that 120. So now I have a polynomial that I'm trying to solve, okay? I'm going to find out what would actually make that 0. So now I'm pretty much just applying the synthetic process to this, okay? I'm searching for a number that will give me a 0 as a result, okay? I want it to equal 0. Well, let's find out. So here, this kind of takes some guess and check work, okay? Because you don't know exactly where to start, okay? So three consecutive integers. So I think pretty obviously you know 1 would be a little bit small to start with, correct? So you don't always have to start at the number 1 and just work your way up, but you do want to make a reasonable guess, all right? So I'm going to guess maybe 2 is my first number, okay? Let's see if that works out. So I'm going to use synthetic division on this thing to see is 2 my solution. All right, does 2 solve this polynomial? So bring down the first number, multiply, add, multiply, add, then multiply, and then add, and you're going to get that. So then you'll notice right away that that is not the solution that I'm looking for, is it? 2 did not work, okay? So if 2 did not work, okay, it was too small, let's try another number. 2 didn't work, let's try 3. All right, maybe 3 will work. So I go through the same process, pull that down, multiply, add, multiply, add, multiply, add. Even 3 was too small, okay? So if 3 doesn't work, let's try again. Let's try 4. Again, I'm searching for just when is this going to equal 0? Because 0 indicates that that's my solution. It's what I want it to equal. So multiply, add, multiply, add, multiply, add, and there we have it. We finally have our solution, okay? So what that means, since we finally got a remainder of 0, it means 4 is one of my solutions. But I wanted 3 consecutive integers. So 3 consecutive integers means I also need 5 and 6. And the neat thing is it's really easy to check this one because you can actually multiply 4 times 5 times 6 to see what you get. And in this case, you actually do get the 120 that you know that you're looking for. So this one is really easy to go back and check your work to make sure you got the right answer. Just multiply them together to see if you got the number you were shooting for. All right, so thank you so much for joining me for this. Please make sure to write that summary for me really quickly, and then make sure you come in ready to do your practice work.